Okay, I believe I am audible and visible. My screen is visible to you. So we will continue our journey on the lab. Okay, so we will continue our journey on understanding different server configurations. If I can remember correctly, last day we had taken the laboratory where we had learned how to create a basic LAN configuration. That was a part of your syllabus in the last year also, last semester also probably. So we had learned some basic commands in command prompt as well as in Linux, where we can find out all the configuration and all the specification related to the network itself. And we have seen that by using basic commands like ipconfig, ifconfig, netshell or any other commands, we can access many part of the network. But simultaneously we have also seen that when we were using those commands, we were basically not able to get all the information relevant to the thing which we were asking for. For example, many times when we were trying to trace a path or trying to find the route of between our computer and a specific server config computer, we saw that many of the nodes was denying with the fact that they will be providing us with the information. This proves that our network is strong enough. This proves that our network is hidden enough so that it can withstand with the external threats. And because we are living in an age of communication, the most vulnerable area is the communication part itself, the computer part itself, where everyone, if he or she is not confident enough, not secure enough, anyone can try to try to steal data from others' computers. Now in today's world, as you have seen through those Bond cinemas or those communication related, those sci-fi series, information stealing is the major concern in today's world, because the monetary transactions, the detailed documentations, all are being kept in digital mode, and if anyone access to those data, those information, then they can create some havoc using those data by breaching in those secure areas. Like you many times see in the newspaper that the government websites have been hacked, US governmentary websites have been hacked, Indian raw websites have been hacked, or ISI websites have been hacked by the Indian hackers. So this shows that nothing is invulnerable, everything is vulnerable. You just need the patience, you just need the intelligence to do that. Wait a minute, let me take a call. Hello. হ্যালো বলুন। হ্যাঁ বলছি। হ্যাঁ হ্যাঁ, আপনি কি আচ্ছা কোথায় আছেন আপনি? ওখান থেকে কি আমাদের নিয়ে আসতে হবে? হ্যাঁ আগের কার্ড আছে, কারেকশান ছিল। ওই আপনি কস্তুরবার ভিতরে আছেন তো? আচ্ছা ঠিক আছে বলে দিচ্ছি, ঠিক আছে। Okay, give me a minute. Let me take a phone call and I'll be back within 1 or 2 minutes. Okay, sorry for the delay. So I was taking a call. What I was saying is that information theft is a very serious issue nowadays, and for that reason, a client-server architecture provides better security, better authentication in accessing the data when we talk about information exchange. Okay, so what we need to do today in today's assignment, we will be learning about to configure a DHCP server, to configure an FTP server, to configure a DNS server, and to configure an email server using Cisco Packet Tracer. These all are a part of the server configuration. These all are part of the client server architecture that we know that are much more secure in comparison with the normal peer-to-peer connection. Like I said in the last day, that if we have two different computers, one is here, another one is a separate computer which are interconnected together or interconnected through a switch network, then if one of them is not a server, হ্যাঁ বলো, আমি ক্লাস নিচ্ছি, ফোন করেছিলাম, one of them so if none of them are server, then anyone can access the other computer's data by some means of it. Okay, if you are not a part of the work group, till you are accessible to you are discoverable, and someone who is having some expertise on this data breaching technology, then he or she will be able to access your data from your computer itself, whether you know it or not. Okay, that's why the client server network comes in, where client server is a hierarchical architecture. It's not a same privileged architecture. So if we take a network like this, a peer-to-peer network is where a client lies here, another client lies here, and they say they have the same privilege. So if it is having a privilege of 1, it will also have the privilege of 1, whereas in a client server architecture, the network, within that network, the first lies the server itself. So server lies within the network itself, then under the server lies the client. So many clients can be lying under the server itself. So client 1, client 2 or client 3, so many clients can be there, and the servers will have a priority of 1, server 2, server clients will have a priority of 2. Even in some cases we can provide clients with different privileges, like someone is having provided with the privilege of 2 and others are getting privileges of 3. That means it's a much more secure way of communication of data between different computers, and the server will be able to identify who has the authority to get some portion of the data and who doesn't have. If the client is having a very low priority, in that case the server will not be providing any information to that client. If the client has a higher priority, in that case server will be handing over the data to those clients only. That's the way we can segregate between different priorities, different efficiencies and different privileges to those individual clients. In a higher organization where everyone is connected to a computer based on their positions, based on their job they are doing, the clients and servers have been divided into different privileges. That's the way to communicate more securely. Now today we will be learning 4 different server configurations if we get time. So we will be starting with the DHCP server configuration. I don't know whether this has been taught in your class or not. A DHCP server is the full form of dynamic host configuration protocol. Dynamic host configuration protocol. Now what does it signify? It signifies that if you have a range of computers in your network, let's say these are the computers which are connected to a network, each one is connected through LAN or any other by means of any other switch, or by means of hub, or by means of something else, then every computers, to connect it to a network, every computer must be assigned with a specific IP of their own, right? They must be assigned with a specific, what is this thing? They will be assigned with a let me just again go back to the pointer pane part. So they will be assigned, each computer will be assigned with a IP address of their own. As you already know, it may be class A, class B, class C, but everyone must be assigned with a IP address so that they can be tracked together. They can be individually tracked by means of their address, IP address. Now IP address, it's a logical address along with the MAC address. IP and MAC together performs the full network configuration of any network, and through which the DNS or the router can access all those individual computers together. Okay, so computer 1, 2, 3, 4, everyone can access the network by means of with those IPs that has been assigned to them. Now these IPs can be of two types. I don't know whether Sumit sir has told you or not. They can be either static IPs or they can be either dynamic IPs. The static IPs are assigned by the users. Static IPs are those IPs which, when assigned to that particular computer, remain static. They do not change. When you switch it off, when you switch on the system, every time when you open it up, that static IP is stored in the ROM of the computer, and whenever you access the internet, that static IP will be used by the computer to connect it to the network itself or to the internet itself. Whereas a dynamic IP is much more versatile, where dynamic IP means it doesn't provide with a static and fixed IP to a specific computer. Like this computer, if it was provided with a static IP of 192.168.0.1, let's say, so it will remain this particular IP for a long period of time, as long as we are not changing it from external point of view. But whereas in a dynamic IP is allocated automatically by the server itself, checking the class ID and they taking the type ID. So that means it may allocate the IP for starting from 192.162.1 to up to, let's say, 255. That means any time when the computer opens or any time when you switch on the computer, if it is allocated with a dynamic IP, আমি ক্লাস নিচ্ছি 25, then every time it will be assigned with a random IP, provided that IP is not shared by any other of the computers within the network itself. That means at any time when you switch this computer on, it may be allocated with 192.168.2 or rather 1.25 192.1 this thing 192.168 .0.1, or any time it may be assigned with the 192.168.0.50, or the next time when you open it up, it may be assigned with a separate ID 0.75. That means each time you open it, it will allocate a dynamic IP. A dynamic IP address means a specific IP address for that particular session. Okay, I have got a question for that particular session as long as the device is in the on state. Let me check. Whereas Aditya has asked how sir, how dynamic IP get to know what that the IP is unique. Now when a range of computers are connected to a say this one, the 4 computers are connected to a network, it passes through a switch or through a hub or through a router itself. Whenever those computers pass through a particular switch or a particular router, the router keeps a track on all the individual IPs that are connected to that particular router or to that particular switch. Those are called as the IP table or the routing table where the IPs are stored. As a result, the IP knows which are the individual devices are on at this moment and which are the devices which are not, and what are the IPs at this moment which are connected to me and they are active in nature. Active in nature means they are accessing the internet at this moment. So when you switch on the computer, if it is connected through Wi-Fi or if it is connected through LAN connection, that means the router will have an acknowledgement that this computer is associated with this IP and it's active. So router keeps a track on those individual IPs which are now in use, and router knows which are the IPs which are vacant on that particular class. Router knows the maximum number of allocation that it can create, and it tries to find out a lower minimum possible value that it can allocate to that particular computer at that time. Say for example, was let's say 192.168.0.1 to let's say 15, these have been allocated, then 16, 17 is now off, then 18 to 19, 20, these are all allocated at this moment. So which are free is 17 and 18. The router will know that 17 and 18 IP is now in inactive mode. So if a new computer opens up and it's being allocated with the dynamic IP, then it is allocated on that either 17 or 18 IP, as long as it's a part of the dynamic host controlling protocol. Now if for example how the dynamic IP can create a clash with the static IP itself, let's say I have got 3 computers, 1, 2 and 3, out of which I have assigned DHCP to 2 computers, and the third one is assigned with a static IP, right? So that means these 2 will be allocated by the router itself, and third one I have said that to 168.1.2. okay, static wise I have said that value will not change, 192.168.1.2. when I switch on this one, on, the dynamic IP will be allocated by means of 168.1.1. when this computer gets on, dynamic IP cannot allocate 1.2 because it's already allocated and it's known to the router itself. At that moment router will allocate 192.168.1.3 because 2 is statically allocated to this particular computer. As a result, dynamic allocator or dynamic allocation will be done on this particular computer, and next IP which is not allocated, that will be provided to that particular computer. Okay, so that's the way the dynamic allocation begins. Okay, now this dynamic host controlling protocol is very well used in local LANs. Like in our computer, if you go through our computer itself, let me just discard this one and try to find out what the IP network and internet settings. Let us try to find out properties. So it has allocated a dynamic allocation of 11.0.1.172. That allocation has been done by the dynamic allocator, and DNS server or the domain name service server is now known. With this one we have already known that this is the CCTV network's DNS server address. It's a Realtek PCI GB family controller, Ethernet family controller. Its IPv6 address is this one, and it's a 100 Mbps. It's connected in 100 Mbps connection mode, and the cable through which it's connected, it is 100 Mbps. So that means it's a 100 Mbps connection. You cannot get more speed than 100 Mbps. And its dynamically allocated IP address is this one, 11.0.1 class A with a 172 is the last segment IP address. So our DNS server starts with 1 and our allocated address for this computer is 172. When you have 200 or 300 computer in your network, you have the option to select dynamic host controlling protocol, host configuration protocol, where every computer will be assigned with a specific automatic IP address. Every time it may change. This time it's 172. After 1 hour, if we switch it off and again switch it on, it may change to some separate address because it's a part of the dynamic host controlling protocol, host configuration protocol. So that depends on how the connection is given. Now for a small network, say 5 to 10 different computers are there, where you can manually allocate all the individual IP address for individual machines. But when we are trying to access a large network, or we are trying to set up a large network having, let's say, 1000 computers within the device system itself, then it becomes impossible for the system engineers to allocate IP addresses to all the individual computers itself. Okay, that's why they use dynamic host configuration protocol for automatically allocating those individual. Now obviously they need to provide that configuration to the server or to the router itself, that from which IP address to which IP address they can allocate to those computers itself. Someone can keep a buffer of say 10 to 20 number of different IP addresses and allocate all the others, or someone may not be able to buffer anything at all. Okay, so let me okay, I have got another question. Static and dynamic should not be same in when it's connected to the same server. No, it cannot be, and it's by logic it's not be. Like I show you that 3 computers are there. One is allocated with a static IP. Let me again draw that diagram I drawn you in the last place. So if there are 3 computers, let's say this is one computer, this is another computer, and this is another computer, out of which 2 have been associated with the DHCP and the last one is associated with the static IP of 192.168.1.2. okay, as long as this device is in the off state, the dynamic IP can be allocated to them anytime, any value you can assign, as long as this device is in the off state, it's not accessing the network connection. But whenever this device is in the on state, if say at any time this has been automatically allowed as 1.1 and this has been automatically allowed at 168.1.2, because this computer was in the off state. Now when this device is becoming on, when this device becomes on, then it's associated with a static IP address, so it cannot be changed. So what the router will find out, router will find a conflict of IP address between the computer number this one and computer number this one, and the router will obviously find out that this is not a part of the dynamic host controlling protocol, so it will change this one's IP address. It will create a information at the screen that there is a IP address collision between computer number this and computer number this, dynamic IP will be allocated. So for 1 second the system will try to reallocate any blank IP address to this particular computer where the DHCP was given, and after certain time you will find that it has been allocated with a separate IP. That's the way dynamic IP resolves those individual collisions. Okay, so dynamic host configuration protocol, you know, it's a automatically allocated IP for individual computers. Now let us understand this by means of packet tracer. How do we configure dynamic host configuration protocol in a network that we are creating for ourselves? Okay, so let us have a let us take 3 or 4 individual computers in a system. Let us take 4 computers or with another laptop. Okay, so what we will be doing, we will try to create some hierarchical formula, hierarchical area, and we will try to add some switch. So our, let's say 2960 or generic switch that can be used. Let us take a switch here and connect those. So for this case I am taking this flash-like YOLO flash-like connection, which is automatic connection. It do not requires different manual selection of the connection table. So I have connected those two via a switch. The third one is also connected. Let's connect this fourth one, and let us take another switch here, and now we are connecting it to the switch to switch connection, and this laptop is connected to this second hierarchical switch. And finally, because we are going to configure a server, we require a generic server. So we have taken a server and we have placed it at the, okay, so our configuration is like this one. We have taken another connection and connected to the server itself, right? So you can easily see that this YOLO means the device is in the booting stage, and when the device boots up, you get to see that the connection is established, like this green areas, like all these green connections showing that the connection is proper. So what we have done is that we have created a hierarchical LAN architecture where a switch is there, a switch which is connected through 4 individual PCs. Then that switch is connected to another switch which is hosting another laptop as a part of its own connection. So we can also take another computer if we want to, like this one, and connect it through the next second hierarchy like this one. So, and the last one is the server. Last one is the server which is connected to this switch. So our main purpose is to create a dynamic host configuration protocol. That means all the IP connections that will be okay, so that will be a part of. Now you can see all the green dots indicating that all the connections are now properly configured. It's not on, but rather they are properly configured so that they can transmit data. Okay, but at this moment we have not provided any IP configuration to all of the computers itself, right? So it's not provided with a IP manually. They have not been set up, even though they are not also using a DHCP configuration either. It may seem like that these computers are working properly, and if you send a PDU, if you send a data, they will be transmitted to the other computer itself. PC0 has no functional ports. That means when you are trying to send a data from one computer to the other computer, there is no IP address provided so that they can communicate to it from one end to the other end itself. That's why it's not happening. Okay, so this PDU is not performing the function of transmission of message from one computer to the other computer. So that's we have to do. Now initially, before setting up the configuration, so we will click the server part and assign a specific what I can say is a specific IP address to the server itself, because server is the boss. Server must be configured primarily. Once you click on the server, you get to see this is the server dialog box that opens, and there are many different configuration interfaces or configuration tabs that you have here. This one, this one, this one, this one, this one, and this one. Okay, so everything is featured, every feature, every specification that is available to the server has been provided here. And for the configuration, we can go to desktop part. For easy configuration, I am not going into scripting of the servers, but rather for easy configuration we will be going into server to the desktop tab. Let me go in a very slow mode. So once we click on the server, we go to desktop part, and using the desktop part we assign a IP address to the server itself. Why? I am going to tell later on. So what I wanted to assign is a server ID of IP address of 168.0.1. So I have assigned a class C address with a .1 server ID, and once I have done that, I just click on the subnet mask and it's associated, it's already assigned with a class C IP class I subnet mask automatically in the server itself. So server IP is 192.168.0.1. okay, so that's the value that we have provided here. Now default gateway we can provide or we do not provide, that doesn't matter at this moment. .1, so we will keep the same ID to the default gateway as the IP address of the server. Default gateway is very much required when you are configuring a router, but that is not a mandatory thing when you are creating a DHCP configuration. Okay, once we have done that, we close this window. So we close this window, try to see which has been allocated, whether it has been allocated or not. So you can see once you open it up, it's showing that the fast Ethernet 0 server ID is up with a IP address of 192.168.0.1. I have not set the IPv6 address, and the MAC address is also given, and the gateway is also given. Okay, so this way I have configured the server's own IP address along with the gateway. Gateway is required to find out the path. Here server is having the same gateway because server is the end device. That's why gateway is the same as that of the server's own IP address. When routers are configured, we need to specify gateway between two different computers, whether they will be able to transmit between two different networks. So we will cover that later on, but we have assigned a server IP at this moment, right? I have got a question. Okay, where we have to go, please explain again. Shojit, please can you repeat what you are trying to say? In the server configuration, how I am configuring the IP address of the server, I believe that is your question. So once we have done creating your network architecture, this is our network architecture, what we have to do, probably I have done some very quick clicks so that you have not been able to understand. So what we need to do, we need to take from this kitchen of different materials, we have to take the materials, and we have to create a server connection, server client configuration. If you just omit the server part, this becomes a peer-to-peer network connection without having any server. Everyone will be client, everyone will be server. Whereas as we have incorporated a server, that does not only mean that if it's a client server configuration, unless we are configuring the server properly by way of having specific specification or specific protocol. So I have attached a server, but this server is not behaving like a server at this moment. How to make sure this server behaves like a server? We have to apply some of the protocols. Either it can be a DHCP protocol, it can be a DNS protocol, it can be a email client server protocol, or it can be a FTP protocol. Any of the different protocols that we want to have in our client server architecture, we need to implement that. At this moment, it's working like it's connected like a normal client. It's not doing its server part operation at this moment. Okay. So first and foremost, these all computers are connected, but their IPs are not being assigned. Okay, we don't need to set up IP address for the switch because it's automatically allocated or dynamically its whole data transition connection. So it doesn't require any allocation of IP address because it works within the same network. It just receives the packet and it transmits to a proper destination. So we need to apply IP address to the server itself. So what I do, I just left click on the server and you have got this dialog box. It's the specification and the characteristics dialog box of the server at this moment. So it's showing as it's a server 0. And it's provided, I can provide IP address from two different point of view. One is I can directly, you can see these are different tabs which are showing different specifications of the server itself. So I can either go to config and click on the fast Ethernet 0 and try to apply the IP address, or I can, so I need to go to config, then fast Ethernet 0 or the Ethernet through which it's connected, I need to click on that, left click on that, and after that I need to go to desktop, or either way you can do that. I can go to desktop and then from the desktop I can click IP configuration. Here you can see that I have not provided any DNS server because I am not creating any DNS server at this moment, but I have created default gateway. A default gateway is the default path through which the connection will be taken from the computer or from the server to the client or from client to the server itself. But this IP address allocation does not mean that it's a server. Okay, as long as we are not using any of the service, it's not accessing or it's not working like a server itself. Okay. Next is, once we have applied a IP address, you can provide your IP address of your own. It doesn't need to be class A IP address. You can give a class A IP address or give a class B IP address also. But for simplicity, we generally go through this standardized IP address allocation like this one that we have done here. Okay. Then default gateway, we can provide this one as well as any other value that we want to, like say 10.0.0.1. We can also put this as a default gateway. So default gateway is a separate thing which is required for dynamic host configuration as well as for router configuration. It's up to you which value you want to provide. Okay, once we close that, then our server is accessible, but we have not provided any IP address to the server or any other of the clients. So these all are clients. To make sure that they behave like a client, we have to allocate dynamic host configuration protocol to the server. So we go back to the server again, or rather we can try to go to any one of the desktops. Say I click on this PC0, left click on it, go to desktop and then go to command prompt. Command prompt is the emulation of running command prompt on this particular PC. It's a PC0 where we have connected. So we can try to ping the server by writing ping.192.168.0.1 and try to see whether it's connected or not. Because our computer itself is not associated with any IP address, that's why it's showing that it's requested timed out, it's not connected. Because our computer itself is not configured, so I am not able to ping the other computer. our PC0 is not connected to the internet. PC0 is not connected to the internet at this moment, so I have not allocated any IP address. So it has sent 4 packets, but it has received 0. That means the data didn't pass through this computer to the network itself. So this data that we had sent 4 different packets, it didn't go from this computer to the network itself. Why? Because we have not allocated any IP, and without the IP it's like a blind person who is trying to see everything. Okay, it's not possible. Now what we want to do, instead of creating a individual IP for the individual computers, what we want to do is we want to allocate dynamically IP address to all those computers. For that we need to configure the server. So we go to the server itself again, left click on it, and we go to the services. Okay, now when you go to the services, when you click on the services, you will find that this server can support these all individual protocols, and we can create server configuration based on these all individual protocols given in this server itself. Okay, where we can find the first one is HTTP, then DHCP, then DHCP v6, which is equivalent to the IPv6, then TFTP, then DNS, then system log, then AAA, then NTP, emails, FTP. These all are individual protocols or server configurations that we can use for our configuration purpose. So because we are dealing with the DHCP, so we will click on DHCP. Right, so you can see our DHCP configuration for the server is in the off state. If we do not switch on the server with a DHCP configuration, the server will not be allocating IP to individual computers that are connected in this network. So we need to first switch on the server itself. But before doing that, we need to apply we need to apply to the DHCP. Before switching it on, we need to make it on so that the DHCP configuration can now be enabled on the server itself. But before going into that, we have to provide a default gateway connection here. Say for example, our default gateway we had provided with a 0.0.1, right? Because we had provided that in the server itself, so I have written that here also 0.1. Let me take this 0, and it's showing that the start IP address, when it will allocate IP addresses, IP addresses to those individual computers, their IP addresses will start from 192.168.0.0. It will start with this one, and they will be allocated with a subnet mask of class C. Total number of users that I can allocate here is 512. That means I can create a network of 512 computer configurations. I can remove that, I can write down 255 also, so that it can be changed and we can make that enable. Okay, so total number of user is 255. At this moment I believe we do not need to allocate the DNS server. The default gateway we have provided as it was written in the server itself. Someone can change to class C also, it's not a very big deal, but it's showing that starting IP address is this one and subnet mask is this one. So it's also showing that server default gateway is not given here because we have not enabled that. Then its starting address, IP address this one, maximum user is 512. That will change eventually once I close this dialog box. Okay, so we have enabled the service. Now let us close this dialog box. Let us again go back and see DHCP. Okay, as per this default gateway again 10.0.0.1. Make it on. Now we go back to one of the laptops, let's say PC0. Okay, we go back to PC0 and try to allocate a DHCP there. In the PC0 we will left click on it, and it will open this dialog box of this layer. We will go to desktop tab and we will click on IP configuration. Here there are two options, one is DHCP, one is static. So we will click on DHCP. Once I click on it, you can find out that this DHCP has automatically allocated, after 1 or 2 seconds, it has automatically allocated a IP address of class C. Remember, it was being allocated that it will start from 192.168.0.2. so they have taken 0 and 1 to be as a reserve, and they have allocated 192.168.0.2 as the IP address for this machine with a subnet mask of this one. So it has said that DHCP request is successful. Okay. So now this computer, as long as this DHCP remains on, it will hold a value of 192.168.0.2. Okay. Now close this dialog box and then try to see now whether it can access the server again. Now let us ping the server again from that particular computer where now we have allocated a dynamic IP. Now you are getting a reply from the server itself. See, because now it's being allocated with the dynamic IP address, now it's part of the dynamic IP which has been imposed. We have not provided any IP address subnet masking statically. Now this IP is being allocated from the server itself, and because now the IP is allocated, I can ping server and it's providing us with the data. So you can see that packets lost is 0, so 0% lost. It has received 4 packets, it has sent 4 packets to the server. We know because the server's IP address is 192.168.0.1. Okay. Now our DHCP work configuration is working properly. Then take the second PC and left click on it and go to desktop. Let's go to IP configuration and put DHCP on it. So our 0.2 is allocated. Now it has been allocated with 192.168.0.3. So this is allocated. Okay. So this is now allocated with a separate IP address, and the third one is desktop IP configuration this way. This one is allocated with 192.168.0.4. So DHCP request successful. So individually one by one I can allocate all the individual computers. So one can try to check whether I can statically configure IP address to a value which is already present. Let's say 192.168.0.3. 3 is already available, so I can see that it's showing invalid IP address entered. So I cannot give that 192.168.0.2. If I try to press enter, this address is already used in the network itself. If I try to put 192.168.0.3, is showing this address is already used in the network. That means when I am trying to put, I can have access to all the other IPs that are in use at this moment. Every computer is trying to see where all the individual IPs which are accessible to them itself. Okay. So I cannot statically put those IP addresses as long as those computers are in the on state. So let us take DHCP and try to see which IP they generate. It has generated 192.168.0.5, which is a separate one. It's now working. Then so 4 computers we have provided, 2, 3, 4 and 5. Then also do the same for this one, DHCP. It will be 6 probably. PS it's 6, 92.168.0.6. DHCP request successful. The last one is the laptop which we have not configured, and DHCP it will be associated with a 7. So 192.168.0.7. Now the DHCP configuration is successful because it's working with all the individual. I have provided with a DHCP on in the fast Ethernet 0. Our Ethernet 0 connection is active and we have assigned with a DHCP protocol. Remember the fact that this DHCP is assigning those IPs. These individual computers are not assigning their IPs by themselves, whereas these individual computers are being assigned with the IP from the server. If we cut down the server, this DHCP will be assigned in an haphazard manner, because I have set the DHCP configuration in the server itself by such a way that our range will be starting from 192.168.0.0. In that case, the range will be followed in this series only. For example, if we just switch off the DHCP, so let's switch off the DHCP, and for IP configuration, let's say give us a static and again go back to dynamic itself. It's not getting anything. It's getting a value provided by the packet tracer itself, but now see, it's showing that DHCP failed, API PA is being used. API PA is the default allocation that is done by the Cisco packet tracer itself. So it's not following the same class, as you can see. So it's not following the same class or the same ID. It's following the class C, but it's not taking the same way of configuring the IP address itself. It's taking a value of its own, 169.254.114.184. That is because we have kept the DHCP server in the off state. That's why the server was configuring all the IP addresses, not the packet tracer one. Okay, so DHCP is not working at this moment. Let's again enable this server, DHCP server. Let us make this one on again, and again go back to this computer and try to move from static to the DHCP. It's showing you, if you have seen this one, I don't know whether you can see the requesting IP address, and again it's being allocated with 192.110.7. See, the problem with this DHCP is that whenever you switch it off and switch it on, the IP address changes. The problem with this one is that when you are doing a secure transaction, if your connection becomes off and if your connection becomes on again, your IP address changes, and as a result the transaction gets disconnected, the transaction gets stopped, because your IP address has changed, and by means of IP address changing is resembled as you have switched the two PCs between two of the different PCs. That's why when you switch on the IP address or DHCP, you make sure that the connection is stable enough as long as the device is in the on state. Otherwise, dynamically the IP will be changed. Like it was holding a value of separate, it's holding now a value of separate. Okay, let's I believe you have understood the way the DHCP is working. Take a look at this one. Let me take a 4 minutes break. I need to take some water. We will be coming back at 3:10 again. Wait for me to come back again. Okay, so we will be covering the three of the things that are left for us to complete. One is this DHCP configuration is now done. To configure a DHCP server, you know how to configure the DHCP server itself. We will be looking to see the FTP server configuration, then a domain name server configuration, and lastly a email server where we will see that how we can send emails between two or n number of computers, automatically creating a mail server within our system itself. It's a very intelligent tutorial that is going to come. It's a very interesting tutorial that is going to come. Please wait for it. We are taking a 5 minutes of break. Okay, we have known how to configure a DHCP server, and we have also seen that without the server configured in DHCP mode, you cannot have a DHCP proper configuration of DHCP. The advantage using DHCP server is that the allocation of the IPs will be based on the server's needs, based on the server itself. It will be what I can say is managed by the server itself. It will not be a haphazard management, haphazard allocation of the IPs. It will be allocated in one by one mode, right? That's the advantage of the DHCP server. Next is how to configure a FTP server. What is an FTP? FTP stands for File Transfer Protocol. It's also another. Let me take the felt tip pen. Okay, let me take the pen out. Sorry. So, an FTP stands for File Transfer Protocol. It's a secure file service protocol which works on TCP IP protocol. It's a separate protocol which works along with the TCP IP protocol. That means you need to have a TCP IP protocol to make a FTP protocol to be happening. Okay. The main purpose of this FTP is that you can create a client server network. So you have got two different computers. Okay, so let us erase this. So you can create a connection between a client and a server. You can create a connection between the client and a server, and the server will access to the file, server will access to its directories to the client itself with some permissions. So server can provide some username and some password to the client who wants it and server can also define whether they will have read permission, read permission, write permission, then delete permission, see all directory permission or not. Server can define. It's only for associated with the things which are related with the file transfer between two different machines. Okay. It's a general file transfer protocol where a server assigns some clients. Server is provided with a list of clients and their passwords and their privileges, whether those clients, when they are trying to access the server, they will have that permission to take the file from that server or not. Okay. Sometimes we do download movies from the file FTP websites. There are many FTP servers throughout the world where movies are stored, softwares are stored, softwares are stored. What we need to do? We need to write down the FTP command to access any FTP server, any FTP website or FTP enabled server. We need to write down the FTP, then space, the IP address or the domain name service or the domain name of that particular server we need to write down. Once we click on it, if it is an open FTP server, then it will not require any document, any username or password. You can access everything that is stored in that particular file server, in that particular server itself, and you can access the data from that server. But if it is a secured server, then you will be provided with a password and username login view, and when you click on that particular login with your proper client name and your proper username and your password, then you can access to that particular site and can get the data from there if you are allocated with that permission. it can happen that you have the client authorization, but you do not have the authorization to copy some data from it. You can access the file transfer site, but you cannot delete or read from it anything you can do. So we'll do that later on. We will try to understand the way it works. So for that reason, again we need to go back to packet tracer itself. Close one, take another one. So we will be starting with another new. Let's take this one. Let's save this one. Save as. So let's save this one as DHCP, then client ver. Those ever who wants to have this packet tracer file, they can request me. I can provide you with the packet tracer file. It's already configured. So we'll erase that and we will create a new one. Okay. So in the new one, what we require is generic PCs, generic laptops, generic PC and generic laptops. Okay. Then we also require one switch, let's say generic switch, and eventually generic server, because everything we are dealing with is requiring a server. Okay. Now we have placed 4 laptops, 4 computers, 2 PC and 2 laptops with a switch. It's a generic switch. As you can see, it's a 4-port switch. It's given. We can switch it on or switch it off and can extend the ports associated with it. Okay. You can see that this is a switch whose back panel has been allocated or shown here. Let me just zoom it out or zoom in. Let me zoom in. So you can see this switch is having 2 auxiliary cables, packet tracer switch, and these are all RJ45 cable connections, that means LAN connections, a 4-port switch that you can see, and by means of changing this toggle switch you can switch on and switch off the router itself or switch itself. So what you can see here is for our configuration we require 4 connections, 1, 2, 3 and 4, along with 1 server connection. So that switch must be having 5 individual ports, but you can see that okay, it can get to 5. Let's see whether we can have that or not. So let us take this automatically close connection type and connect one by one to individual switch to the individual computer itself. Why this is red? Because we have not switched on the computer. Okay, so it will become eventually 0 once the switch boots up. Now it's booting up and the client configuration is being provided, so that's why they are all in the green mode. Now once I connect this one, it's a 5-port switch. As you can see, the cable cannot be connected to that port. That means there is no provision of connection. So what we need to do, we need to add extra port to it. So because our LAN connection has only 4 ports, so we need to take another port from it. When the power is on, you cannot add any module, so we need to power it off and we need to add this module. Okay, and power back again. So now we can connect another connection to the server itself. See, now it's connected. So the switch was having 4 ports, so we have added another port and now the connection is now working. It's not configured, but it's working. So what I wanted to do is I need to assign IP addresses. So for that reason I will go to config. Let us go to server first. Let us go to server first and click on it, so that this brings us with this new dialog box window, and in the global settings you can click on fast Ethernet 0, and when you click on fast Ethernet 0, that means the LAN connection, you can have a IP configuration dialog box here. In the IP configuration dialog box you can provide a IP address here, say 192.168.1.2. Let's say it's a class 1 IP address, it's given here. Now I close this one. Now a server is configured properly, its IP address is given. Let us allocate any other IP addresses to other computers. So take PC0 and go to again config, then fast Ethernet 0 and provide a separate address for that. .1.3, because our server was of 2, let us authorize with us 3. It's a separate IP address with automatically assigned subnet mask. Close it, then go to laptop, then go to config, then fast Ethernet 0, allocate another IP address 4 with automatically assigned subnet mask. Close it, go to another computer and go to fast Ethernet 0, then 192.168.1.5, allocate. Now go to last one with the fast Ethernet 0, 192.168.1.6. Now sometimes we require to know which computer is assigned with which IP address. For that reason we can click on the double server 0. This can open up this command prompt, or where you can write down the IP address 168.1.2. Here you can directly see which IP is allocated to which one. So you can 1.3, click on laptop 0, 192.168.1.4, 192.168.1.5, 192.168.1.6. Okay, so this way I can have an idea of which IP is allocated to which one. Okay, this is a normal configuration that is provided. So we can go to any one of the computer and go to desktop and go to command prompt and write down ping the server address. So 192.168.0.2. okay, if I can remember what was the IP address I had said, 1.2, right? So if I go to laptop again and ping the value, its request is timed out because I have made a wrong ping request. Let us close this one. .2, it will be 1.2. So it's getting a reply from the server. It's fine. I can access any other of the computers like 6 and I can also get the reply. That means every computer is connected to everyone. At this moment it's not working with the FTP server or any other of the server, but it's still working. The server is also working like it's a client peer-to-peer network. It's also behaving like a client. Now the server is not working as a server itself. To implement FTP, what we have to do, we have to go to server and go to services, because it's the place from where we can access different protocols in the server area. So we have to go to services and we have to select FTP. So you see here, you can see that FTP is given. So go to FTP and make sure that is in the on stage. Make sure it's on. So you can see that our FTP is in the on state, and many things which are given, like a Cisco as account is already given, whose username is Cisco, password is already Cisco, and it has the password. I can save it, I can keep it or remove it. It's a default FTP ID that is provided by the Cisco itself. So we will not be doing with this one, but rather we will be doing with separate values. So we will keep this one as off and then make this one as on, and we will close this one, rather close this one and go back to FTP again. So what from here we can create our FTP web server. FTP web server means The original server will be stored in the server that we have configured here. All the users, all the PCs can only access the FTP server if they have the username and the password, and those usernames and the passwords will be decided by the server manager or the network administrator. Say I want to access the server, I request the network administrator to provide us with the username and password. Network manager provides us with a username and password by how? By going to this FTP configuration and providing us with a username and password along with the usage details. Okay. Say for example, I am creating a user whose user ID is student and password is also student, let's say, and I want to make him only read only option. Say for example, I am using a college server and you are a student, so I will not be giving you the permission to delete anything, right? So delete or rename, that's a no thing. So I give you the permission to read only. So I have created a username student, let's say this password is also student, and he can only read the permission, or he can only read anything which is there in the FTP. Read means anything which is publicly available in the FTP web browser, and nothing else can be done by this particular client. Okay. And what I do, I click on add, and you can see that a new user have been created whose name is student, whose password is student, and his permission is only read. Now if I want to add myself to this, I will be creating another user NB, my acronym, then password, let's say it's also NB, and I provide myself with all the individual options that are there for accessing the site. So that means write operation, read operation, delete operation, rename operation, and list operation, everything is assigned because I am the privileged member, right? So then I add this user also. So you can see NB with a permission of RWDNL, right? So everything is accessible by this user, whereas this student doesn't have any permission. The advantage with this FTP browser is that it's not device specific. That means when you have done this one, there are 4 individual clients associated with this computer, and each client is associated with a specific IP, but FTP server is not IP specific. That means I can log into the FTP server from any one of the computers, 1, 2, 3, 4, anyone, and with using only my username and password. Obviously if I have the username password of any other client, I can do that also, but I don't require to be IP specific. I can access the server from any one of the computer in the organization itself, as long as I can access the FTP server. Okay. So what you can do is that you can directly try to go to this particular say you are trying to access the FTP server from laptop, and you click on it, you go to desktop. In the desktop there is a option called web browser, right? This web browser, you can write down FTP space 192.168.1.2, that is the server IP address, and try to see what is coming out. Nothing is coming out, that means FTP cannot be accessed here. Okay. Then what to do? We have to go back to command prompt again and try to see whether this provides us with a value or not. So we write down the command FTP, that indicating that we are trying to access the file transfer protocol in the server, then 192.168.1.2. So it's showing, let me just zoom in. It's showing that the packet tracer PC command line, that means packet tracer's own command line interface. I have given the command FTP with the server IP address. It's trying to connect. It has connected to that particular website or that particular FTP browser, which is FTP server, which is held at 192.168.1.2. it's showing that welcome to PT FTP server. That means now I am being welcomed to the FTP server, but I require to enter the username which has been previously allocated. Now if someone comes and tries to find out this command, they will be provided with this login screen. It's the interface between entering to the FTP server and non entering to the FTP server, right? So because we know we have been already allocated with the FTP usernames, so I need to write down student. Let's say you are trying to log in to FTP server, you just write it student. It's showing that username okay, but need password. That means password is necessary for entering to the FTP site. Okay, so I enter student again because that was our password. Press enter. Now logged in. It's showing that passive mode on. Passive mode on means directly I cannot do anything. What I can do is I can try to browse between different commands that are available. Let me write down help. Now you can see that the command prompt has changed from PC to FTP. Now we are using FTP server's own command cell. It's not a part of the normal server, but rather it's a part of the FTP server part where I have already logged in. Without the password it could have not been possible. Here you can try to view all the FTP commands that are there, and these are the commands I can access when I am within the FTP link. That means I am actually using the server, FTP server at this moment. I am logged in that server using the student username. Let's say try to see the directory structure dir. So it's showing that listing FTP directory from 192.168.1.2 error, no such file or directory, or permission denied. So it's finally showing that requested action not taken as the permission is denied. It's showing that I don't have the privilege to get the directory architecture in that FTP site, in that FTP server more specifically. So if your student account is having less privileges, that means you can log in, but you can only access some limited part of the FTP server itself. You cannot access all the things. So what you can do, you can write anything, you will find out that everything is being denied. PWD or password, it's not showing anything. Then a get remote file name, I need to check to the files, but if I am not able to get the directory or the files that are stored in that particular server, then it's not possible for me to write down the name of the file that I am trying to get. So it's not possible. So this way the student login ID has been specifically used in such a way that it can access to the server, but it cannot get anything from it. What to do? We can quit from here by writing down quit and pressing enter. Now we are again within the PC. Now we have brought back to the PC cell from the FTP site, and we will try to again log in, right? So we will try to log in again by writing this one 192.168.1.2. Now again the same interface that connected to this one. Welcome to PT FTP server. It's asking for username, and I know my username with the privilege was NB, so put it that. Username is okay, need password, then it's NB. Logged in, passive mode on. Now again write for some commands, so it's help. Let us now see what the other operations bring to us. Okay, so I will be seeing the directory structure which was being denied in the student itself. So I put down the right name directory, and now you can see that because I am having the privilege of read, write, delete, rename and list, all the individual permissions were granted to my account. I can access to all the individual directory. It's showing that listing FTP directory from 192.168.1.2. That means everything that is stored within that particular file transfer protocol browser server that I can access. Even that is not the thing, I can delete any file that is shown here. So it's starting with 0 to 18, that means 19 different files are stored, or 19 different emulation files are stored there. I can access them, I can rename them, I can check the password if there is stored any, I can get any file, I can delete any file, I can change directory of any file, I can create a directory because I have the privilege. Okay, that's the way the file transfer protocol works. Now you can have an idea that this different protocols work very good way when we work in a client server architecture. In the same computer, it's being performed from the computer. Let's close this one. So it's I am just trying to access this computer 192.168.1.6. So I have accessed everything from this computer. It's not a device specific, so I'll also be able to access the same sites from this computer also. So if I go to this and go to command prompt and try to ping or rather try to access the file FTP 192.168.1.2, then again I am getting the same way. It's also connected to the server. Let us check NB, then password is NB and it has again logged in. Now again I am checking its directory, I am able to view. So here also I am getting the same view. So it's not device specific. You are located in V3 building, let's say in our college, or you are located in B1 building, or you are accessing one lab, you have moved into another lab. If your lab assignments are stored in an FTP site, for example, let's say your assignments have been stored in FTP site and the teacher has provided with you with your username and your password, you can log in from anywhere in the college itself and have an access to the files that are stored in the FTP site itself. That's the benefit of FTP. FTP protocol is a file transfer protocol only. It's associated with the file transferring. It's not associated with the web page opening or domain name system or the domain name server operations. For that purpose, we need to look into the third part in our assignments, is to configure a DNS server. So far we have seen that the configure a DHCP server, dynamic host configuration protocol. It assigns different IP addresses automatically, which is required to maintain a large amount of internet network connections. If your computer network has large amount of connections, you can automatically assign IP addresses and your DHCP server will maintain all the individual IP connections. Router sometimes plays a DHCP server configuration for allocating IP addresses. Next, we have understood how to configure an FTP server and access data from it. How can we remove permission from individual? Let us go back to the packet tracer and try to find out what happens when we go back to the FTP server. So go back to the FTP server and go back to FTP itself. If we just take NB from our point of view, so if we just select it and remove all the permission, so you can only read but not any other values. So you have again modified it and now we are trying to access the same value, same command from any other computer or from that computer, say FTP 192.168.1.2. So NB is the username, NB is the password, then directory. Okay, so it's not showing because it's still in the same stage. Let me go back and switch off the FTP. Okay, still, okay. My mistake, I have not saved that attributes. Save, now it's read. make this one on and try to access the same commands, same nb. Now I try to access the directory, it's showing that permission is denied. That means from the server everyone can remove the permission, everyone can add the permission of any user. Okay, so that's the beauty of the file server client server architecture. Frankly, when you see computers in our computer labs, they are not a part of the client server architecture, they are part of the peer-to-peer network computer. There is no server that is present in our university, only routers are present. A Vodafone router is which is for accessing the internet, and local routers are there for connecting all the individual B3, B1 and B2 individual connections. So this client server architecture would have been made the network connection much more secure. Okay, that's the beauty of client server architecture. So let us save this one also. Let us save this one. If you require, we will get back to that. So FTP client server, we will rename that file FTP. Now we go back to the domain name service. Okay, now we go back to the third one to configure a domain name server or the domain name service server. What is a DNS? If you know that DNS is like a phone book, DNS is like a phone book where two things are written. If you can remember what a telephone directory would have been looking like, it's a book where each one of the person's name, its address along with its own unique telephone number is given. The same thing is given for the DNS server. A DNS server holds the IP address along with its own logical name for individual web pages, individual websites that are there through which we humans access websites. Now if we require to access all the individual websites by means of their IP addresses, it could have been a disaster. It would have been a disaster that if you want to access google.com, you go to this IP, then this IP, then this IP and so on. If you want to go to yahoo.com, you go to this, you ping to this IP, then to this IP, then to this IP and so on. So it could have been a disaster, but otherwise the domain name server, what it does, it matches. Okay, let me check whether any other okay, no information at this moment, no questions at this moment. So when we are having a domain name server, so when we query something means when we write down www.google.com, that query goes to the domain name server, and domain name server find out its address resolution protocol. ARP tries to find out is equivalent IP address or the original logical IP address, and then it tries to find out the final IP address and goes back to that particular server to fetch data. So domain name server works on the way of creating a query of accessing a specific website and finding out its equivalent IP address, then finding out the data from that particular IP address. So I have got 15 minutes. We will try to find out whether it's possible for us to complete this experiment by today or not. So wait for it. Let me make me 1 minute break. I'll be taking 1 minute break only. So what we require again an architecture like that we had drawn in the last case. So we will take again, let me just take a very quick PCs. So one generic PC, two generic PC and three generic PCs with a switch. It's a generic switch we will be taking, and again we require another server. So a server, okay, we'll connect them together. Connection like the way we did. So we'll go back to this experiment in next day also if possible. I believe this day it will not be possible. So first we have created a basic network architecture based on this client and server. So these three are the clients. Let us find out the IP addresses we will be providing. So 192.168.1.2, or let's say it has a client of 1.1. Then PC0 will be assigning with a separate IP address 192.168.1.2. Then PC1 with the 192.168.1.3. Then the fourth one is 192.168.1.4. So 4 IPs I need to assign. So let us go to the server and configure the IPs. Let us give a IP address of 192.168.1.1. Subnet mask is automatically given. Here we will not be putting anything on the default gateway, but rather we will put a value on 192.168.1.1, the same address that we have used for the IP address. Okay, so we have not changed anything. Then for the second computer it will be 192.168.1.2, and the DNS server will be the server that we have given in the server itself, 0.1. okay, .1, the IP address that we had given. Then IP configuration again 192.168.0.1, rather sorry, let me go back, 0.3, but the domain name server will be the same of the server that we have configured, 1. Okay. Then the last one, desktop, then IP address 192.168.0.4, I believe, this one, and the DNS server will be 192.168.0.1, the same ID that we have provided as a server's DNS server, right? Once we have done that, we can go to server and go to services and go to DNS and turn on the service. DNS service must be turned on. Let's say we are trying to find out mypage.com as an website, so we type that. I am just showing you today because we have got 8 minutes left, and the address remains 192.168.0.1. okay, so we add that page. It's showing it's like a telephone directory where I am storing a record, like the name is, or name of the person is www.mypage.com and the details are 192.168.0.1. it's the telephone directory is telephone number. The main name, people finds the website's name and the details are obtained based on the IP address of it. Okay, so DNS is provided, then we require the HTTP, so we will delete all those things. We delete all those things. Okay. We'll be going in details step by step mode in next day, but before that let us create a new file, index.html, .html, and we'll paste that value and we'll change this body to welcome to my page. My name, let me write it my name. Okay, so save it. Now HTTP showing this one. Now from any one of the client, if we try to go to website and try to ping, let's try to ping from the command prompt whether our server is accessible or not. Ping then 192.168.0.1. okay, did I do something wrong? 1.1 that I have given, and I am saying this one to be 0.1, right? So it should be 0. This one also should be 0. Its IP connection is 0.1, 0. Let it make this one 0. This one 0.3. There I have done the mistake. 0.4. So let me just ping it again. Now I am getting reply. That means our server is connected in our network. So what we will be doing is we go to web browser and try to ping 192.168.0.1. Now see, our web page is opening. The web page that I have created in the domain name, in the server itself, that is opening itself. So let us write down www.mypage.com. Let us close it. Write down www.mypage.com. And this HTML we have created, that whenever I write down mypage.com, it will open a page like this one. I can change this one to be like anything. So as long as HTTP connection is correct, so I can edit this one. Welcome. This is a lab class. I can change this one to any color. Lab class of computer networks. So if I save it, yes, rewrite it, and then I go to any one of the clients, say for this client, and I am opening a web browser. It's a demo web browser, so I write down www.mypage.com, this lab class of computer network. Sorry for the English, but you can access to any one of the websites which is stored in the server itself. So that means you do not have to write down the IP address there, but rather as you have mapped that IP address to your domain name, or map the host name or the ID web address with your IP address in the domain name server, you can directly access from this DNS itself, because you have stored this mypage.com with a record with its own equivalent IP address of 192.168.0.1. So next day we will be dealing with it more details, how to create a domain name server, and lastly we will be creating another network where we will be sending one email from one computer to another computer, and we will get a reverting mail from another to the new one. Okay, so thank you for joining. For next day's assignments, please submit these experiment number 1 and experiment number 2, that is to how to configure a DHCP server and how to configure a FTP server using packet tracer, and after next day we will be doing the last 2, that is to configure a DNS server and to configure an email server. So thank you for joining. If you have any queries, we will be having in touch through WhatsApp, and if you require I can send you with the packet tracer files. Thank you very much. Have a nice day. Stay safe.